so this is going to be a simplifying an expression with factorials. So 20C4, you're going to have to grab your formula sheet. Okay, so on my formula sheet, I'm going to look at this formula right here. So the top number is n factorial. So this is going to be 20 factorial divided by r factorial. So that'll be the 4 factorial. And then how do I do it n minus r? What number value would that be? If you do n subtract r, 16. And I'm also dividing by a 17 and a 19. Okay, so what's the rule about factorials? You start expanding the bigger one. Okay, so I'm going to start to expand 20. How do I know where to stop? What's your goal? Where do you go to? To 16. Okay, I'm also going to have to expand 4 factorial. Okay, so I guess technically this on a provincial exam would be in a section without your calculator. So I know that this factorial and beyond cancels that factorial and beyond. Just the number 19 cancels the number 19, right? There's no factorials on those. 17, 17. Okay, can we just reduce stuff? What do you want to like cross out with a reduction? We could probably say that we could divide the top and the bottom both by a 4. So I would cross out the 4 and I could cross 20 out and replace it with a 5. What else could you do? If you weren't allowed a calculator, I could cross out a 3. And then if I cross out the 3 out of the 18, 6. Are you at a spot where you can do it in your head now? 5 times 6 is 30. And 2. So 30 divided by 2 is 15. Okay, so we could do that all without a calculator. Okay, next one. So I'm going to expand the factorial that's bigger. So you have 2 choices, the n plus 3 or the n. Which one is bigger? N plus 3. So n plus 3. The down one, n plus 2 is down. Keep going down, n plus 1, n factorial. So I stopped there because I saw one of those on the bottom. And that n plus 2 doesn't have a factorial on it, right? It's just an n plus 2. Okay, so everything from here on out would have canceled with everything from there on out. That cancels that. And I'm left with this binomial times that binomial. So what would you do in math if it told you to simplify something? Simplify means if I simplify 4 times 5, you're going to simplify it to 20, right? So how do you simplify this? You have to multiply it. So that'll be a FOIL, right? When you multiply it, n squared plus 4n plus 3. FOIL that all out. Okay, n plus 2n, they're both factorials. I'm going to expand the bigger one. So n plus 2, n plus 1, n factorial, n factorial. I can cancel. So I think this is basically the same idea as the last time, so I'm simplifying. So I'm left with okay, be careful on this last one. Which of those two numbers is a larger number? N plus 1 is larger than an n minus 1, right? Okay, so n plus 1. What's one lower than that? N. Keep going, one lower. Now I can stop. Okay, so when you see negatives involved, be careful with thinking about which number is lower. So I'm going to cancel. And then you have to be really careful how you write this answer. We should make sure we write 1 over, right? I would see that mistake quite often, just forgetting to put it on the bottom of a fraction. Okay, so don't forget 1 over if it looks like that. Okay, solving. So those were expressions. We simplified them. These are equations, so we're going to solve them. Okay, so I'm going to expand. Which one should I expand? I'm thinking n plus 2, right? It's bigger. Okay, n plus 2 and expand it. What are we going to expand it all the way up to? An n minus 1. So go down, go down, go down, all the way to an n minus 1. Okay, equals, and then I'm just writing the other side. Okay, now I'm going to cancel, so that would end up canceling if I divided by both sides. I could also divide both sides by n plus 1, leaving me with that, which I will expand out. So can you multiply those two? So n squared plus 2n. And the right-hand side is just 35. Okay, grade 11, we learned this strategy. What should we do when we see components like this in an equation? We should zero one side. Now it looks familiar, and we're going to factor it. So I'm thinking I'm going to use a 7 and a 5. Okay, now what do you know about factorials? What's the lowest you could ever be on a factorial? When you do factorials, what's the lowest value you can factorial? 1. 1. You can't go to 0, right? 1 is the lowest. So if I'm plugging -7 in, it's creating a -5 factorial in that. So that's not going to be good. I can't do a -5 factorial because factorials, all the way to 1. 1's the lowest you can go. Okay, and the last question, I'm going to go back to my formula sheet. So here I have, okay, ready? We're going to go n factorial. Can't do anything with that. R factorial is going to be 2 factorial. N minus R factorial. Bless you. I can't replace n, but I can replace r. Okay, so that was the formula replacement. Okay, now what are we going to do? We're going to expand out of those 2 factorials. Which one's bigger? So the n go down, so n minus 1, go down, n minus 2, and then I'm going to factorial that and stop. What is the value of 2 factorial? It's actually just 2, right? Because factorial means 2 times 1. Okay, so I'm going to cancel that. So on this top, I get n squared minus n. And can I do this at the same time? Would you be okay if I wrote equals 90? See where I'm getting that from? Because of the 2 on the bottom, I'm just going to times both sides by 2. Okay, so now I'm going to maneuver the same way. I'm going to move the 90 to 0 a side out. I'm going to factor. And in this situation, you can't have a negative because -9 choose 2. That doesn't even make sense, right? You can't choose 2 objects from -9 options.